It's almost time for today's show to start. Guys, by the way, we have a huge number of registrations today. People sign up for this show. About triple the size of a typical IBM room. Lots of interest. Well, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the Db2Night Show, episode number 209. I'm your host, Scott Hayes, president and founder, DBI Software, and IBM Gold Consultant and IBM Champion. Today we have two special guests for you. Wow, what a great day for Db2 education. Klaas Brant from KBCE is going to share with us the perfect Db2 server, and that's going to be a great presentation. And then Db2 11.1.4.4 has just become available, and we've got Rodger from the IBM Canada Lab. He's going to share with us what's new in that release. In the interest of time, we're going to skip the usual commercial today to try to save some time, and we're going to move really fast through all the goodies we have today. So, Kelly, how are you today?
Very good. Hi, Scott.
And hello to you. Yeah, I had a question about the photo I found of you on LinkedIn. It kind of looks like somebody stole your beer.
I think my wife took that.
Oh, okay. It's like, dear, what are you doing with the camera? All right. Ask about that. Klaas, how are you today?
I'm fine. Thank you, Scott. How about you?
I'm fabulous. Fabulous. Rarely
Almost your
better.
birthday.
Almost. That's coming next month. Yes, sir. So follow us along on Twitter at Db2Night Show. If you do any tweeting, there's the handles there. You got Klaas, got Rodger. Join our LinkedIn group if you haven't yet. There's the usual show disclaimers. We're recording, mind your manners, etc. Very quick announcements. Then we're going to get you the perfect Db2 server. Klaas is going to take a break, and we'll wheel in Kelly to share with us what's new in version 11. Do some quick studio audience polls, just a few, and then we'll wrap up and bid everybody a happy December. Quick announcements. Hey, this afternoon, don't miss this. One of DBI's webinars is running at 1 p.m. Central Time. How to tune Db2 LUW in minutes with confidence. We give everybody a $10 Amazon gift card just for joining us in that webinar. Get there at dbisoftware.com events page, and you can register for that. Upcoming shows, 21st of December, it's our eggnog party, and Martin Hubel is going to present indexes versus prefetch, how to win the fight. And 14th of December, Christian Valero, Distributed Access, Db2 for Z, top things you need to know. And we're going to have more shows for you next year as well. We're getting those planned now. Congratulations, Olaf Mueller from Ethica in Toronto, Canada. How about that? Yeah, a Canadian won the Amazon gift card. So that's going to be worth like maybe $40 or something. He was a member of show 208, 10-minute triage with Michael Krafik. He completed the survey after the show, and his name came out of the lucky hat. We'll get that out eventually soon. Maybe we'll do those today. A giggle of the day, don't mind me just picking up their Sears Christmas tree. I thought this was cute. It is the holidays after all, and everybody needs one of these in their living rooms. And what else do we have for you? I saw this on TV the other night. If you take Prince Philip, add orange juice, add vodka, you get a Phillips head screwdriver. It's just a lot of fun. Klaas, let's learn about the perfect Db2 server. I'm going to make you the presenter.
Okay, let me make sure that we get the right screen Okay, do you see my screen?
I do see it. It's a beautiful screen.
Okay. Well, I have to warn the people. It's announced as a 75 minutes, but it might run over and take a bit longer because I have a lot of slides. But hopefully you find it that interesting that you will still be there by the end. Okay. Well, disclaimer on trademarks, etc., etc. Just telling you that if all fails, it wasn't me. And of course, I want to do a shameless plug as well. In a week's time from now, I have another basics workshop. We just had one in the Netherlands. That was cool. We had a lot of folks signing up for that. And we're doing it again in a week's time. And if you register because of the show, you get the early bird discount, although that period is already over. So hopefully I'll see some folks over there. Let me start with my uncle. You probably all met my uncle, Dr. Bob Sbeeters, and you've probably seen him at IDA. You know him as Dr. Bob. And he always tells everybody, they who don't take care of tuning will never have good performance. So take these wise words of Dr. Bob, and let's see what we can do tuning-wise to make it the perfect server. If we look at the server components, there is the hardware triage about CPU, memory, and disk. The three together form a kind of balance. If you want more of the other, then you probably also need more of something else as well. They keep each other in balance. And on top of that, we have the Db2 config to make sure that we make the best out of the components which make up a server. And then, of course, there's the fifth component, which is your application. That's the SQL. And so you can have the best of the best server in the world. And if you have crappy SQL, you still have bad performance. And we'll talk about that also a little bit at the end. So we're going to talk about first about the three components, CPU, memory, and disk. So let's have a look. So this hardware trinity, you could say, is the CPU. If that becomes too busy, then everything else fails. So if you are completely maxed out on your CPU, you will find that other things are starting to fail as well. You probably are doing also a ton of I/O at that time, and you probably might even run into memory problems, etc., etc. Same thing about the memory. If you start to do swapping because there's a lack of real memory and you are overcommitting, then you are killing performance totally. And the same thing applies to I/O. We all know that I/O takes time, and that's the thing we don't want, that it takes time. We want fast performance on our transactions, and therefore our disk must also be at top performance and hopefully minimum amounts of I/O. So let's have a look at the first component, which is CPU. So the more cores you have, the more threads you have, and that's good. But the more cores you have, that has, of course, a license impact. You pay IBM by the cores, you could say. And so that is always a bit of a problem, that if you want to upgrade and you want to have more cores, then yes, the price of your Db2 will go up. Some folks ask me, how about hyperthreading? Does that make sense or not? Is that something which is helpful? And in general, the answer for hyperthreading is no, because those are not real cores. But there's always a but associated with it. If the process which it is servicing is I/O bound, then hyperthreading can actually be useful. It can make a little bit of a difference. And since the overhead of doing hyperthreading is extremely low, and also since hyperthreading does not count in your amount of money you have to pay to IBM and the vendors, I would say experiment with it, and maybe the hyperthreading, for instance, if you do a lot of I/O for I/O cleaners or prefetchers or stuff like that, the hyperthreading might benefit you a little bit. So typically, if it doesn't work, then it doesn't hurt, you could say. Under normal circumstances, CPU is typically not the bottleneck, except when you are doing bad SQL, and we're coming back to that. But make sure that the average percent busy of the available CPU, that's not the real CPU, as we will see in a minute, of the available CPU, that must be lower than 8%, you could say, maybe 85%, but definitely the average must not go beyond, let's say, 90, because then you are maxed out and then you are starting to run into trouble. So make sure that you keep it under 80%. And I know that a lot of folks are implementing VMware, for instance, virtual machines, because they want to make sure that their CPUs are actually being used. So be careful with that. We'll see that in a minute, what that is. So, of course, also the license can put a limit on what you can do with these CPUs. And actually, that if you have, like in this case, this is a developer C, that says you can have maximum of 4 cores, then you can plug in 8. That doesn't work, then it stops at 4 cores, you could say. Okay, then in order to guide the workload through the server, you can use Workload Manager. But the Workload Manager is a very difficult thing to understand. I'm talking about the Db2 Workload Manager here. And it's also very difficult to configure. It's not an easy kind of thing. And most people leave it as it is, as it comes out of the box. But you can definitely say that if you have queries who use a lot of CPU, that after a certain amount of CPU, they fall down in priority, and therefore that they don't have that big impact anymore. So an easier thing to do is, if you are working with VM, then you can typically, within the VM, you can assign a maximum and a minimum amount of CPU, and the same kind of thing also applies to memory. And that can help you in making sure that you have enough CPU available. But there is a bad side attached to that, and I'll come to that. So if you start to combine the two things together, it's like what it says on the slide. You are trying to dance with a bear on a sheet of ice. That doesn't work. So be careful with that. If you are doing VM, then don't expect that Workload Manager is going to do anything for you except making your life miserable. Like I said, SQL can ruin any good server. And so if you have one bad SQL, which is called an elephant, that can eat up all the CPU, and the same applies to a lot of very small SQLs, but many of them are called mosquitoes, and they also eat up all the CPU. And we'll come back to that at the end of the webinar. All right. So, and some components within DB2 are CPU hungry, and we must try to avoid them to happen, you could say. Like the SQL compile is a very CPU intensive process, and therefore we want to cache our SQL as much as possible to avoid the amount of SQL compiling going on. And there we'll see that some of the components within DB2 are extra, they are counterproductive, you could say. So we'll see that in a minute. So here you see an example. This is Hyper-V, but it could just as well be VMware, that you can specify in these kind of tools the maximum and the minimum amount of RAM. And also the same thing applies to the CPUs. And that makes it very, very difficult, because it makes it difficult that you have a certain amount of memory and then suddenly that changes. That is also a problem, you could say, for tools like STMM. So be careful in these VM worlds, but like I said, it can be in a production kind of an environment. It can be a lifesaver that you can just throw in extra amounts of CPU when you really, really need it. That, of course, has a downside. The downside is that this CPU has to come from somewhere. That's why I said the available CPU. That is, if you start to configure a server which has like 24 cores, and you are starting to fire up 10 VMs with each 4 cores, then there is a bit of a problem, you could say. And that could mean that if one of these VMs becomes really, really busy, that it starts to steal real CPU from the other VMs. And you can typically see that, for instance, here in the Linux top, at the end, there is this with the red circle, which is the stolen CPU. If you see that the stolen CPU actually is not 0, then you have a huge problem, at least for this Linux you're looking at. And if that number goes up, then tuning more or less becomes useless, because there is something going on in the box that you don't have the amount of CPU which you think you have, and that is a very bad thing. So be careful not to overcommit if you are in a VMware environment. Okay, next component, which is the real memory. And this is typically the most critical part of any server. Memory is a very, very important thing to all databases in the world. If you start to have huge amounts of memory, then typically you will also see something in the operating system which is called huge pages. Huge pages are like in AIX, you can have them at 16 megabytes per frame, and in Linux and Windows, you can have them at, I believe, 2 megabytes a piece, which is different from the normal 4K pages. Why is that done? That is done because if you have so much memory, like a box with like 256 gigabytes of memory in there, then 4K frames actually are a lot of overhead to manage for the operating system. And if we can make that easier and simpler for the server, then that is a very welcome thing. If you have huge pages, you must also tell DB2 to use the huge pages. There is a new trend going on that you can have huge pages, but to the outside world, you still mimic as if it's 4K pages. So be aware that that exists, and make sure that you are actually making the right choices. I would say don't enable huge pages unless you have a CPU problem because of hardware interrupts. Okay, now back to our DB2. We want to run a number of DB2s, number of databases probably, on our server, unless this is a huge production server which runs one instance with one database and that's it. But typically you have multiple databases, and a lot of folks also run multiple instances because they know that if the instance crashes, it takes along every database in its path. So it's not uncommon to have two instances, for instance. But that makes it very, very difficult to do the planning, because what we need to do is we need to make a memory map for our server. We have to do some planning to make sure that we chop up the amount of storage we have and give every instance and every database enough to work with, you could say. And the other thing is that our workload typically grows over time, and therefore the need for more memory is there. So that is something you have to decide how you deal with that. Maybe you want to reserve an amount of storage. Maybe you say, well, this is for future growth, or you plan at a certain stage to upgrade the server or to move a database to another server. Make sure that you have plenty of swap space. Swap space is important. Because that's your lifeline if things go wrong, you could say. If you are overcommitting and there is no swap space, or the swap space is not rapidly available, then we'll see in one of the slides very nasty things are going to happen. So make sure that swap space is there, and there's plenty of it. So it must be like 100% of real storage up to a maximum of 64 gigabytes. And then you have to start to think about, well, does it make sense to have more than 64 gigabytes? Like I say, it's a lifeline. It's not supposed to have the double capacity of the real memory. Any type of swapping kills DB2. Well, having said that, swapping out is not bad. It's the swapping in which is bad. If the swap in is because DB2 needs that piece of storage, then I have to wait for it. If Linux wants to swap out something, well, who cares, you could say. So that is something the modern kernels are actually doing just as a safety, you could say. They start to swap out things which they still keep in memory, because they know if they in memory need something very rapidly, they can give it up and they know it's already out there on swap space. So this is something you will see, that if you have swap space enabled, and you say, hey, that's weird. There is still plenty of free memory, but you see that the swap space starts to be used at 1 or 2 or to 5%. It's like, who is swapping that stuff out? Well, that is Linux actually doing it because it's not really used, that memory. And so it says, well, maybe I want to give that up later, you could say. So it starts to swap it out. That has to do with the swappiness. And this is a thing which is always under debate. Definitely the one thing you don't want to do is to bring the swappiness down to very, very low. If the swappiness is 0, you forbid all kinds of swapping. But if you bring the swappiness down to like 10%, then that means that actually it starts to swap when things starts to get critical, you could say. So the lower you bring it, the less the kernel wants to swap, you could say. Therefore, my motto is don't tamper with the swappiness. I know that the swappiness is rather high in a normal server, and that means that it starts to swap out things. Who cares as long as it doesn't swap it in, you could say. If you get under stress, you could say, and the swappiness starts to forbid or is very reluctant to swap out, then we'll see that bad thing happening with that. It starts to kill things. Well, on the memory side, there is a lot of information presented to you. And that information comes from stuff like top and free, and you can do a cat of the proc mem info. And sometimes that looks all very conflicting, you could say. I will show you in a minute that you can actually look from the inside of DB2 to what it's using, and that probably gives you a better figure. So take a look, for instance, at this tiny little server. It's only having 2 gigabytes of memory, and therefore it's typically always under stress. It starts to use its swap space, but you can see from the top already that swap space isn't used by DB2, you could say, because if you look at the green bars over there, you can see that actually DB2 is only utilizing 13.6% of the memory, you could say. So there must be a lot of other things going on in this server, which it was. And that is another warning for you, is that if you run DB2 on a server, make sure that you run DB2 on a server and nothing else. And so be careful in doing other stuff next to DB2. Actually, what I prefer to have is a real database server, you could say. But I know you probably want to run batch as well, and you might want to run some other things, but be careful with that. One thing always to keep in mind is that the VMstat, for instance, as you can see at the bottom of the screen, you can run that for a period. This is 2 periods of 60 seconds. And that VMstat can already show you the swap in, swap out. And as you can see, this server is actually swapping in. We don't know whether it's for DB2, probably not. But this server is swapping, and therefore this server is not performing very well, you could say. So let's have a look at the memory picture of DB2. And this picture should, if you are working for DB2 for a longer period of time, this picture should look familiar. This is top down from where DB2 consumes its memory, you could say. So at the top, there is the instance. The instance is overlooking everything, you could say. So all the databases run within the instance, and therefore the memory is allocated by the instance, famous process called sysc, and that has a limit on the amount of memory it can allocate. So that includes all of the databases, and you can set that in the DBM config at instance memory. So you cannot go beyond instance memory, you could say. I will talk about automatic in a minute. Then, of course, there are the databases who are active. Hopefully you activate them in a production environment by yourself. Otherwise, they are activated by the first connect, but also the last one turns off the lights, and that is not a very good idea. So the amount of databases which can become active is limited by numDB, and the amount of memory the database can consume is limited in database memory. Okay? underneath the databases run the applications, and the applications are limited by Apple memory, typically something you don't tamper with unless you have very, very specific needs. And the maximum number of applications which can be simultaneously active is in max apples, which is something different from the amount of applications which can be connected. So this is the maximum number of applications being active. So how can we, oh, I'm going the wrong way, isn't it? Oh, no, this is good. The instance memory. How can we look at the instance memory very quickly on what we are consuming, you could say. First, let's take a look at the DBM config, and you can see instance memory is set automatic, and then you can read the number there, and those are 4K pages. And there is a command for Db2 PD, which is database partition memory, so dbptn-mem. And as you can see at the bottom of the slide, and that shows you the memory limit with the yellow arrow. That means if you multiply that number by 4K, you get that amount of K. And our current usage is like already very near to that, you can say. And you can see also with the red arrow how far we've been since the instance was active. It actually has been already more or less at its limit, you could say. So that is very interesting. Then it shows underneath that little stats, it shows you where the individual databases are consuming, and also by itself it needs some memory. So you can see what is consuming the memory. And I'll come back to that in a minute when we do the monget. You can see the same amounts as you can see in this Db2 PD report. Okay, back to our memory overview, and this picture is a more detailed list, and it shows you again the 4 layers: instance, database, application, and within the application there's also some private memory being used for certain processes. There are lots and lots of config parameters which are influencing the amount of memory you are using. They all come from configs, except for the buffer pools. The buffer pools you do with DDL. All the other stuff comes from either the database memory config, which is the yellow dots over here, or it comes from the DB config, which is the purple dots over here. And there are a number of, there are a number of things which can be tuned by STMM. Sorry, that's the purple dots is STMM. The red ones are coming from DBM, and the yellow ones are coming from the database. Phew. So as you can see, that STMM can influence a number of areas, making them more dynamic than what automatic means. Okay, let's come back that later when we look at STMM, what STMM is doing and what automatic actually means. So how can we look from the inside out, you could say? Well, there is the monget memory set, and that tells you on this instance who is consuming what, you could say. And you should actually add that up so you can see how much you are using in total, you could say. And that gives you similar figures as the Db2 PD does. And so if the database name is blank from monget memory set, that means we're talking about the instance. And typically the instance doesn't use that much memory for itself. There's not a lot going on within the instance, you could say. All of the work is done within the database. And so we only have one database active in this example here, the sample database. And there you can see it splits it up in the 2 layers, the layer database and the layer application. You will typically see that the layer database is pretty fixed because these pools are allocated and that's it, more or less. They are, from that moment in use, these are the buffer pools and some other areas which are fixed, you could say. Whereas the application, that's the one which is actually fluctuating a lot. The more applications you have active, the more you start to use for applications. Therefore, this picture is actually quite dynamic, you could say. And it's very important that we are monitoring the high watermarks, what is being used. Okay, now, if we look at this query, it says set size, committed, and used. What's the difference between the three? The set size is what it really can allocate, you could say. That is from the config. But the committed is what it actually has asked the operating system at the moment, and it can go up, you could say. So you could say that, for instance, the database might not have yet allocated, for instance, the utility heap, because no utilities has been run yet. Therefore, you can see that the committed is lower than the set size. Then it tells you what is actually being used internally, and that can be even much lower, you could say. Again, what is most important is that you monitor the high watermark, is how much memory did we actually use at a peak moment, you could say. And if you have an instance running for a week, this query can be quite interesting, so we can see what is what and who's consuming what, you could say, but only from the active databases. So don't deactivate your databases. You can see similar figures from, if you don't want to write the query, you can see them from DSM top. If you go in DSM top, you go to memory and then to instance, you will see the same figures. It's the same kind of query. But unfortunately, DSM top doesn't add it all up for you, so you have to be there with your calculator and add it up for them all together, so you can have an idea. So very important, don't deactivate those databases, because then the high watermark is lost. There's another thing going on if you deactivate databases. We'll come back to that in a minute. If you start to wonder, it's like, what is actually going on within my database? Who is consuming all that memory in my database? Then there are two options where you can get your information. Again, Db2 PD, and you use then with the -db which database you want, and then minus mempools, and it gives you an overview. But as we know, Db2 PD is a very technical tool, and it tells you all kinds of things. It's like, huh, what is that? So maybe you're better off in doing yet another monget. There's a monget memory pool, and that is more clear on what's going on, you could say. So that is, it's also telling you in more human terms on where it's used for, you could say. So that is very important as well. And again, you can see from the monget memory pool, the last column there is again the high watermark, which is quite interesting for us. So we can see, for instance, is our utilities, are they actually using up all the memory or not? And that could mean that maybe you can make your backup run faster because you do more parallelism. You of course need more memory, but you can make your backup faster if you have parallelism going on. So have a look there whether you are actually utilizing these memory pools to the max, you could say. Okay, coming back to the configs. The configs set a lot of things to automatic, right? And there's actually almost every parameter can be set to automatic now. Well, look what happened to me here last week. We were experimenting a lot during our training. And so this is running on an Express-C server. And the Express-C server says I can have 2 CPUs and I can have 16 gigabytes of memory. Do I have 16 gigabytes of memory? Well, not. It's just for a training. So I only have 4 gigabytes of memory, which is enough for a training. But then when I activate a number of databases, at a certain moment, I activate the so many database. And as you can see at the last thing on the slide, Database Manager failed to allocate share memory because Database Manager instance memory limit was reached. It's like, what? It's like, I thought that was set to automatic. Let me check very quickly. Grab memory, yes, it's set to automatic. Okay, that's weird, because if it's automatic, shouldn't it just break out that limit and then just grab more? Because when you look at on the previous slide, oh, are we maxed out on the memory on DB on the top? No, there's still plenty free. If I do my Db2 PD again, I can also see that, yep, that's the 2.3 gigabytes, so it's not even near to the 4 gigabytes. No swap space used, lots of free memory, but I can't activate that other database. How is that possible? Well, most of these automatic parameters are actually to allow for growth, you could say. And that means that if you give a little push, then actually you can push through the limit and make it a bit higher, you could say. But it's not snake oil that you say, well, if you just ask for a huge chunk, that it says, oh yeah, let's break through the automatic limit. That's not the case. It's just that if like stuff like SDMM gives a soft push, it can break through the automatic limits. And the same thing applies to many of these database config parameters. There's another thing you should know about the automatic in the config is that most of these automatics, if they go up, they don't come down anymore. So if you set them to automatic and you set a certain parameter to 10 and you give a little bit of a push, it might go up to 12. But from this moment on, your config says that it's 12. And that means that if you deactivate and activate again, it becomes active with 12. That means that also databases tend to grow over time. And what happens here is that definitely when SDMM is available, that if you have a instance memory at a certain limit and you activate a number of databases, these databases start to eat up the memory within the instance memory. So let's just say you have 5 databases, each more or less gets 20%. Maybe one is more active and SDMM wants to push that towards the 25%, so the other ones have to give in a little bit. But that's what's happening here. It's like it's eating up the amount of instance memory. Now, what happens if I have 5 databases at 20% and I deactivate one for a longer period, like a couple of hours or maybe a day? Well, the other 4 is like, yay, that's nice. Room, let's eat the memory. And therefore, it starts to eat up the memory up to the point where if you want to activate the database, same thing happens as on this slide. Couldn't allocate the memory anymore, and therefore you can't activate. Ooh, really, really bad, right? But another thing can happen as well is like, look at what it says here on this slide. It says that the current usage is very near to the memory limit. Isn't that weird? It's like, how come can it be so close to that? Well, that's our friend SDMM. What happens if you activate a database and SDMM is active and it doesn't fit? Well, SDMM is your friendly helper here, and it says, you know what? Let's just reset the config to default parameters, and let's see whether we can activate now. Yay, that worked. So this was the one which I activated just before I tried to activate the one which failed. This is from the dialog, and look what it says. Level warning is like, whoa, that's bad. It's like I typically don't look at the warnings, but in this case, I was just scanning through the whole thing. It's like, that's a weird message. So be aware that SDMM, although it's supposed to deal with only 4 memory areas, that if worst comes to worst, then SDMM says, you know what, I can reset the config. So that is something you have to be really, really careful with. Okay, talking about SDMM, what is this bugger? How can it help us? Is it good? Is it bad? It's like, we all know that Scott isn't too much of a fan of SDMM, but I'm an inexperienced DBA and I have no idea how to do the tuning, and this is autonomic computing. I turn it on and life's happy and everything goes by itself, right? Well, just be careful. I told you already, the warning is that you better make sure that everybody who uses SDMM is active at the same time, or they might eat up your free memory. The other thing which I hate about STMM is that it actually is interfering with things I don't want it to interfere with. And that's the package cache. The package cache actually is caching the compiled SQL. And as I told you in the beginning, compiling SQL takes a lot of CPU. Therefore, I don't want that once I've compiled an SQL, that this SQL actually is pushed out too quickly. And the package cache is by default already too low in the config. It should be much higher. The package cache should be much bigger than the default suggestion. And I agree with Amber Crooks that the package cache you shouldn't touch from that moment on anymore. It's like, leave it. Don't allow anybody to touch it because it's a very precious thing. So then it only has 3 memory areas left which it can tune, which is the sort memory, the log list, and the buffer pools, which the buffer pool is clearly the most important one. And so it's like, is this really, really that useful? I don't think so. What I typically do is I turn on STMM for a while and look what it's doing. And if it stabilizes itself, I might agree, and then I turn it off, and from that point on, I leave it where it is, you could say. So this is what STMM is working with. So from the database config, it must be on, and then it can interfere with the database memory, the log list, the max logs, etc., etc. So that is, if you have STMM on and you like STMM as a tool, then I would suggest that you follow up what it's doing, that you have an idea on what STMM is actually tinkering around with, and you can do that. There is an STMM log, but that's a whole lot of in a text file. But IBM wrote actually a very nice Perl program, which you can find on DeveloperWorks, which parses that log and actually turns it into a very much more usable thing. So make sure that you have the STMM log parser if you are using STMM. And think about it whether you really want it.
You could use DBI or a tool to track the memory allocation as STMM is tinkering with all your memory. Are you at a breaking point by chance?
Yes, almost.
Okay.
Then I'm done with the memory. Then we'll take a break.
Okay.
So turn it off. That's my suggestion. Turn it off, and then that's also Scott's suggestion. But like you said, is use DBI to follow up or whatever, so you turn it off completely, or you turn it off by area you don't want it to interfere with, and that means that you fix it. You don't set it to automatic anymore. You give it a fixed number, and then STMM cannot do anything with it. And most of the things STMM is doing is dynamic. Last one, and then we'll take a break. The killer. I told you that if things are getting under stress in the memory, and you cannot benefit from the swapping, you cannot actually swap out or swap out quickly enough, then there's a little helper within Linux, which is called the killer or the reaper, and it will actually kill the process who has allocated the most memory. Well, guess what? Who is allocated the most memory in a database server? That's sysc, that is Db2. And as you can see, this is from the dialog. This is very severe, that an unexpected error has occurred and the instance has to shut down. And in the Linux log, you can actually read that the killer has selected sysc to kill it. So that is a very, very bad thing. So that completes CPU and the memory, and then we'll take a break, and we'll then talk about the disk after that.
Excellent.
Back to you.
Thank you, Klaas. Okay. Let's do a quick polling question while Kelly gets himself ready. What Db2 LUW versions are you running in production? Checking in with our audience now. Make sure y'all are awake. "30 seconds or 80% of the audience." Move those mice quickly. Okay, going once, going twice, closing the poll, sharing the results with our audience. And today, 10.5 is the winner with 85%, 61% on version 11. 33% on 10.1, 33% have 9.7. All right, that's great. Keep that old code alive. What operating systems? This one's a fun one to watch. It used to be AIX was always the winner. And then recently, x86 Linux has become the dominant operating system for Db2 on distributed platforms. Let's see if that holds true with today's audience. I remember when we started the show years ago, AIX would be 70, 80, 90% of our audience, and x86 Linux would have a very small showing. Things have changed. Okay, closing the poll and sharing the results. Today's operating system winner is AIX, 72%, x86 Linux, second place at 67%. Now with a showing for Linux on Power and Z-Linux as well, Windows is still alive. One more polling question. Are you using Db2 in that fluffy cloud thing? AWS Cloud and IBM Cloud, another cloud, not yet considering the future. No way, no how, not for us. These databases in the cloud. I know I've been working on databases in the cloud since about 1992. That's the first time that I logged into a server that wasn't at my desk. It's the other end of the office building, but, it wasn't at my desk. It was in the cloud. Going once, going twice, closing the poll, sharing the results. 17% AWS, 8% IBM Cloud, 11% another cloud, 44%. Not yet, thinking about it. Almost 20%, no way, not for us. And I have one last. Are you using PureScale? Been watching the adoption of PureScale grow over time. Db2 version 11.1 made it easier, more fun to use. It's kind of difficult to configure prior to 11.1. Let's see. Give you a few more seconds. Catch a couple more votes. Wiggle the mice. Click on the buttons. Going once, going twice. Closing the poll. Sharing the results. 11% of today's audience is using PureScale. 31% not yet, but thinking about it. 57% no need. And that is an entirely reasonable position to take. We're not going to have a commercial today, but I will remind you that DBI has been honored trend-setting products 5 years in a row by Database Trends and Applications magazine. How about what's new in Db2 11.1.4.4 with Kelly Rodger? Kelly, let's get you on.
Yeah, let's share my screen here.
Yeah, I gotta find you. There we are. I'm gonna make you the presenter. There you go. Click that button. We'll see your screen.
Perfect.
It's the slide deck and.
All right. Hopefully that shows up full screen eventually for everybody. So yeah, thanks, Scott. I'm Kelly Rodger. I'm one of the senior development managers in Db2 development here in the IBM Canada Lab. I'm accessible in email and Twitter and LinkedIn and all the usual places.
Excellent.
So far, as many of you, according to the poll, are aware, we've been rolling out regular updates and function and fixes to the 11.1 code stream roughly twice a year, approximately. Boosted in between by some interim fixes of critical fixes that we think everybody will need.
Kelly, I'm still seeing your title slide. You might not be in slideshow mode yet.
I changed myself to full screen. Let me see what I can do.
There we are.
How's that?
That looks like a slide.
All right, good. So perfect. We'll go with that. All right, that was the slide probably everybody missed then. We can skip past that. So 11.1.4, mod 4 of the 11.1 life cycle. Many new things here. Let's go through a few really quickly, give everyone a taste. So we're now supporting Power 9 hardware on supported operating system platforms. There are a couple. There are some outstanding issues with some of the software stack that impacts pure scale and some HA configurations, but otherwise for base DB2, Power 9 is working great. We also added some new pure scale platforms, which will be of interest to some percentage of the audience by the poll. So SLES 12, the latest updates from SLES and Red Hat on the platforms listed here are both also supported for pure scale environments now, which is excellent. Russelbin, I know you mentioned that 11.1 made pure scale a lot better, so those who are using it will be delighted to hear there are quite a number of management, cluster management and usability enhancements in 11.1.4, too many to walk through here. I would recommend that if you're interested in those, go have a look at the Knowledge Center. The What's New outlines quite a few of them that may be of interest to you. There are also a lot of performance improvements, tweaks, optimizations that, it's performance, so your mileage may vary, but hopefully many people in the audience here are able to benefit from. So a couple of notable things we'll call out. Online backups. If you've ever had problems where online backups, due to a large number of change pages, do significant buffer pool flushes and cause a performance impact that you're not happy about, there has been a fair bit of work in this mod pack to streamline that and to flush with much lower costs. So this is off by default, but there is a registry variable you can turn it on if you're interested in that. And hopefully that will be noticeable for many people. Also, users of mirrored logs. So also off by default, but it can be optionally enabled, is a function which can do asynchronous higher performance mirrored log I/O for environments where you're using mirrored logs and actually have a substantial impact on log performance if that turns out to be a bottleneck for you. I'm sure many of you are also familiar with backup restore statistics, the bar stats. They've been in the Db2 diag after a backup is complete for quite some time, and you could always retrospectively go through and analyze how you're performing and look for bottlenecks in your overall systems. So this has been enhanced recently. There's a new Db2 PD option where you can examine much of the same information that would show up in the bar stats historically, but it's also further enhanced, and you can view it, of course, through Db2 PD while the backup is running and see online, relatively live statistics, even beyond what you would have normally seen in the Db2 diag log. Oh, I think we skipped one there. All right, federation. Quite a few enhancements to federation connectivity for those who are interested. A number of new data sources or enhanced data sources for platform currency, where they're updating to newer versions of other products. I'll list a few of those here. And JSON. So we have had some JSON capability for a little while now. What this is, it's the first wave of making publicly available ISO JSON SQL interfaces. The existing systools interfaces will continue. They're supported. They will be de-emphasized. That's not a discontinuation statement or deprecation, but these new interfaces of external standards will be the focus. There's lots of details in the Knowledge Center about each of these. They're a little easier to use. You don't have to preface them with the schema because these are sys-IBM routines. And by all means, please use these. Let us know what future enhancements beyond this you're interested, because this is not the complete interface, and as I said, it's just the first wave of enhancements. HADR. If you are an HADR fan, user of reads on standby, perhaps, they're one of the most significant pain points that we've been aware of for a while is that if a DDL statement or some maintenance log records were replayed on the standby, this could cause a replay-only window that would kick off application connections and cause some pain for probably some of the people on this call. So now there is a switch. You can turn on a fairly significant enhancement here so that when that switch is on, if a DDL or maintenance log record is replayed, We do not automatically enter a replay-only window and kick off all the connections. Only those applications which are running on the standby, which hold locks that conflict with the operation directly, those will still be impacted. But otherwise, we hope you get much better availability for more applications. Wow! That wasn't scary at all.
We like that one.
That was not expected. Love it. So PureScale Extent Reclaim. Extent Reclaim, of course, has been available for quite a while, but never available in PureScale environments. So now the alter table space reduce command, reducing, trying to move used extents down into unused space, lower in the table space, and lower the high watermark of the table space, is optionally available again through a switch to toggle it on. And hopefully very valuable to PureScale customers. So we're really happy to see that get out and live into the field. A tech preview. So this is kind of exciting, not something we do all that often. So this is not for production use yet, but we definitely want people's feedback on it. So if you have an opportunity and you have a device which uses 4K sectors, by all means, try it out, turn on the switch. Give us feedback. Either you can contact us directly if you're a participant in the Db2 Early Access Program beta. That's a great place to provide feedback. I know the development team that's working on this would love to hear from you. So there's a couple of restrictions on the initial support, that it's not available in PureScale and raw containers. And I think even SMS table spaces with no file system caching is one of the others that comes to mind. But by all means, we know this is the future direction for a lot of software and hardware platforms. So give this a try. Certainly, this support will be enhanced in the future, and we're hoping to get it into production use as soon as we can. So Db2 11.1.4.4 available now. It's out. It went live, depending on your time zone. It would have been late Tuesday afternoon, possibly Wednesday morning would have been when you see it, depending on where you are in the globe. So what's next? The expectation is that for the 11.1 code stream, that 11.1 mod 4 should be the final functional modification of 11.1. We will, of course, have a long life of fixed pack streams and APAR and security updates for 11.1. But right now, the plan is to move future features into vNext. And if some of you have been to IDOG or some of the other conferences, you would have seen the, I think, the Horn of Plenty diagram that some of my colleagues were showing, the relationship between the various Db2 product lines on-premise and in Docker and in the cloud and on the appliance. We'll be working to unify those in an upcoming release where the next batches of significant new function should be landing.
So that would be like an 11.1.4.5.
So the next releases on 11.1 will probably be 11.1.4.5, 4.6, 4.7, and so on for years to come. And then something new beyond that, there will not be 11.1.
I can hardly wait for next year.
Stay tuned for that. We'll have another call.
Okay, right. So you just volunteered to be a guest next spring.
Don't mind at all. So stay in touch. I mentioned the Db2 Early Access Program. In case people aren't already aware, there's a link here. You can register and get early previews. We were shipping routine updates every 4 weeks of the 11.1.4.4 before it became publicly available, and we will change that to be something else sometime very soon. And of course, the future roadmap of these product lines, plus several others that are related, are all available online for everyone to see and comment on.
Nice. We'll have a copy, a PDF of your presentation in the replay blog for people to refer to. And the audience goes wild.
It's a big crowd.
Yeah. Okay, let's get Klaas back on. You're finished, right?
Yeah, all done.
All right. Well, thank you very much, Kelly.
All right. Thank you.
Klaas, making you the presenter to resume your awesome presentation. And Klaas, your microphone is muted. I didn't mute you.
Here it's on again.
Now it's on again. There you go.
Now it's on again. And if everything's okay, you will see a disk. So our next topic is we're going to talk about disk. And I have to warn you, when we talk about disk, that's almost a religious topic, since disks is sometimes or very often not an area where the DBA should interfere with. So go away, we have our disks here, and you shall use what we provide you. So, but we're still going to talk about disks. So a classic disk is a spinning disk, which is very old already, and they can go very, very fast, like up to 15,000 RPM. And that means that you have an arm which moves, that has to seek to the right position, and depending on a whole lot of things, you can have a access time between 4 and 15 milliseconds. And that means that you can have a number of IOs per second between 50 and 250 for random IO. Well, they've modernized the disk, of course, a lot. They have command queuing now, which helps in the seek times. They have lots of memory on the controller, which caches a lot of the sectors, and so on and so on. And therefore, you typically see that the spinning disk can have a access time even lower than 4 milliseconds, going to 1 or 2 seconds, depending on the nice features it has. That is still very, very, very slow compared to the solid-state disks. The solid-state disks can, on average, have something like 50 to 60,000 IOs per second, and there are very good solid-state disks which actually perform like over 100,000 IOs per second. That compared to 50 to 250 IOs per second, that of course is stunning. So spinning disk is old school, and the future will be bright. We will all have solid-state disks, right? But that might take a while, because to have a huge amount of solid-state disk is still expensive, although that might be going away very rapidly or not even be true anymore. So that is how good a disk performs also depends on the throughput you're going to have on that disk. And if that disk isn't attached locally, then the bottleneck is the attachment, you could say. So if that comes in via a network and the network is 10 gigabit, then that is the maximum amount. That is still better than maybe serial ATA that is maxed out at 6 gigabits per second. But you can have fiber attached SANs, which are actually producing huge number of IOs, allowing you to consume those within the server. So in that sense, these disk arrays can be extremely, extremely useful. So, and that brings me automatically to my next slide, is that a SAN, is it worth it, you could say? Yes, for a production environment where you need the huge amounts of IO and having them attached in a proper way, then they are expensive, but they are worth it, you could say. They are a total overkill for what I see every now and then, that it's attached to a single server, which is not that busy. The amount of IO is not that much. They're even mounted within the same rack on the same power grid. Is like, are you kidding me? It's like, if that thing catches fire, your SAN also catches fire. So these could just as well be locally attached disks. And for your average kind of application, the time has come to consider again whether the SAN is the best option. Well, a lot of folks will say, are you crazy? Because we do the SAN, we share that with a number of databases, with a number of machines even. Okay. Well, wait a minute. Be careful that you don't run into the same situation as what you typically see in the cloud at the moment. Cloud storage, the disk storage, sucks, and really, really big time. If you take a Ubuntu Linux machine in the cloud, you do a test, and you are so disappointed. The disks which are available to you perform at 50 IOs per second. Why is that? Well, the cloud provider has this huge SAN, like with 80 terabytes or more, and they divide that over 5,000 VMs, and they limit each of these VMs to have a maximum limit. And therefore, be ultra careful if you go to cloud, how your disk is actually working, and how much IOs you can do and what the throughput is. So you should do proper testing. And if you read carefully, you can also see that these cloud providers are actually also trying to sell you disk storage, which is performing, but that isn't cheap, and therefore the total amount of money you have to put down to run your database in the cloud can actually go up very, very rapidly. So be careful with that. Like I said, is try for a average kind of application to consider local disks again, especially now they can be SSDs, which can be locally attached to the PCI bus, and therefore they can actually perform 60K or more. And therefore, we used to say that we needed a lot of small disks because we wanted to have a great number of IOs. Well, these guys perform very well just by one single disk. So you can plug in 1 terabyte disk, and that's it, more or less. Because if your database isn't bigger than 1 terabyte, then that is one disk which can perform at 60,000 IOs per second. So that is very, very nice. Of course, if you have locally attached, make sure that you have multiple disks, that there is a RAID, there is a failover, etc., etc., etc. Are you worried about failures, that your server catches fire? Well, that's why we invented HADR, and so that is then probably the solution. Still convinced you need a SAN, and like I said, in a big production environment, the SAN might be really, really nice. Then make sure that at least you have a local SSD in your server for temp space and swap space. So just one single SSD, and you know that it isn't really used, and if it's used, then it should be really, really fast. So there, an SSD is really, really good. If you have local disks, a lot of folks always ask me, it's like, what should be the formatting and what is the best formatting? And I don't think too much about it. They are all more or less the same. So I use ext4. That works probably for everybody. What is important that you want to consider logical volume management within Linux. That gives you the maximum flexibility to extend your disks if your disks are full with the minimum amount of problems. So that is also very important. Good to know some commands. If you go to Linux command line, you type in lsblk, just list my block devices. It shows you all your block devices and their mounting points, and so they're the file systems. If you want to follow up on your server on what's going on, use tools like nmon or iostat. Here he is again, nmon. If you want a very, very quick speed test for your disk, use the hdparm with -t. If the hdparm doesn't work, you have virtualized I/O and therefore probably sucks. If it works, then you can see very, very rapidly on how the disk throughput is. So that is very important to know. And if you try that on one of your VMs, you might be shocked. It's like, is that all? Yes, that's all. Always have separate file systems for your data and your logging, because if the file system fails, then either the data is corrupt or the logging is corrupt, but not both. So don't put them onto the same file system. You might consider the separate file system for archives and backups, because archiving and taking backups is a lot of sequential I/O, and that has a big impact. While a disk is writing a lot of sequential I/O, it can't seek. So that, of course, isn't that important with SSDs anymore, but for spinning this definitely is. Another topic is the 4K page size for a database is really, really old-fashioned, although it's still the default within DB2. If you have one of these fancy tools to do your I/O testing to see how it's performing the disk, you will see that 4K blocks and 8K blocks have more or less the same amount of IOs per second, but the throughput of 8K is better. Therefore, if you create new databases, you should definitely consider 8K pages instead of 4K pages. Have separate LUNs for each storage path, otherwise it doesn't make really much sense. And if you have lots and lots of prefetch going on, have a look at the registry setting Db2 parallel I/O. You might get some benefit out of that. You can read all about it in the manuals.
Hey, Klaas, what do you think about 32K pages as default?
Well, for OLTP, then you are moving 32K blocks at a time for one record you might need. And there it starts to, if you do the I/O test, you see that beyond the 8K, the 16 and 32K, the I/Os per second really go down very rapidly. So therefore, the 32K pages are only useful if you do a lot of scanning, you could say, that you actually bring in one I/O a lot of data. So I keep it to 8K. That is, for a lot of data, very nice. So why are you asking that question, Scott?
Well, I just wanted your opinion on it. I think that makes sense. Smaller pages for OLTP, larger pages for data warehouse. And
yeah.
And if you have a blend, then someplace in the middle, maybe.
Yeah, and then the nice blend is actually still 8K, because if you compare the 8 to 16, then we'll see that the throughput is going down, and also the IOs per second is going down. So you want to service those OLTPs very rapidly, and 8K is very nice. And combined with compression, that might even be bringing in still a lot of data. Okay, little bonus, wasn't on the list, network interfaces. These, I see a lot of folks configuring the network interfaces incorrect. If you have multiple network interfaces, they're not supposed to go to the same network, period. Although even the operating system might support it, it's not intended for that. It's intended for that one network interface, for instance, goes to the SAN, and the other one goes to the end users, you could say, and they have nothing to do with each other. If you put them to the same network, you will see that the throughput actually doesn't improve at all. And that's because you are counterproductive because of the TCP/IP on the network, is that while one communication is going on, another communication cannot go on. And therefore having two cards connected at the same time from the server doesn't double the throughput. So that doesn't make any sense at all. So beware of that. And while the other things on the slide is more or less nice things to know, be very, very careful also with VMware, that if you start to virtualize these network interfaces, typically their performance goes really down very rapidly. So all the VMs can provide you with the real network interface. And that's what you want, that you say, well, you can virtualize anything except my network interface and my disks. They should be real. If that's not possible, then go away with your VM, you could say. Yeah. And also make sure, I see that mistake sometimes, that if you run local DB2 work, mistake very often made with Java programs, that the program selects the wrong type of attachment, and therefore it selects a JDBC type 4 connection, which it should have been locally a type 2, because then it's memory to memory. And guess what it does if you do a local attachment with a type 4? Then actually you go through the TCP/IP local loop net, so what the loopback network, and it slows down stuff enormously. Make sure that local work is always type 2. Okay, we've seen a lot of config parameters, and so what a lot of people always ask me is that, how can we improve on the config parameters? And my first question always is, have you tried the auto-configure? And a lot of folks are not aware that there is an auto-configure command. So there is an auto-configure command, and it actually looks around and tries to give you advice. Some advice I take and say, that's a good suggestion. Some advice is, well, no, don't touch that. That was on purpose. So make sure that if you run the auto-configure, that the apply is set to none, which is not the default. When you run auto-configure, it wants to configure. So make sure that when you run the command, you do it with none. And this is how I run the auto-configure. It's a very quick example. So we say this is for a single database. It can use 100% of all the memory in the server. The workload type is simple, meaning OLTP. It's populated, so have a look on the disks and the number of table spaces, etc., etc. The priorities on administration, and so apply none. And then it comes back, and it has areas on the database manager configuration, and it has also advice on the database configuration. And as you can see already, it comes back with stuff like the package cache size, which should be different. And I still disagree here. It goes from max apples times 8 to 1278. I would definitely, if I bring up a new database, my package cache size is 8,192 pages of 4K. And that's where I start. And from that point on, I see whether I need more. And so this is like 1/8 of that. And so that is not very good. So you carefully review what it comes back with, but it definitely very often pinpoints to you as like, that is not really good. But sometimes it also comes with advice like this one, secondary log files. It wants to set that to 0. I don't know. I like a few secondary log files. Okay, so make sure that you run that every now and then and look at the suggestions it gives you. Final warning on that area is you already saw that on the previous slide. They talk about agents. So the agents is the internal multi-threading technology which is in use by DB2. And a lot of the config parameters have to deal with agents and also are configured by the agents, the amount of agents which are available. And one thing to be very, very careful with is that you are not using the connection concentrator, which means that the maximum number of connections is higher than the maximum coordinated agents. Typically, it isn't in a standard configuration, but I've come to some customers who have been tinkering around with the configs and for whatever reasons they try to experiment with it. But having the connection concentrator on has a very serious impact on performance. Don't do that. It gives you a stuttering kind of server. It's like sometimes it's good and sometimes it's like, why isn't it performing very well? So especially when things are getting a little bit busy. So make sure that that isn't the case. Okay, which settings should I change in the config? So we've done with the hardware. We've seen with the hardware a lot of configuration things. And that's a very common question, is like, what should we change? Well, the log timeout is by default -1, which is not a good idea for performance. But the problem is what to set it to. Is it like, when do you kill something if it waits too long? And if you don't know as a DBA, don't leave it at -1. Put it onto 60. 60 seconds is a darn long time to wait. So make sure that you set it to a figure instead of wait forever. The utility heap size is typically much too small for good utility performance. So make sure that you are actually set it to a good figure. And this is one of these parameters you might even want to experiment with, that if in the weekend you do a lot of utilities, that you bump it up and bring it down again by the end of the weekend. And there you benefit from that the memory not being in use with a lot of applications, you can allow the utility heap to be a little bit bigger. The block non-logged, I always disallow non-logged actions. That is very bad for recovery, and you can only see that in the dialog, that it tells you that it has kicked out a table because there was a non-logged action, and therefore you run into surprises that you cannot access that table anymore. The package cache size, don't put it to automatic, put it to a static figure. Start with, like I said, 8,192 if you have no clue at all what it should be, and from that moment on, monitor it, you could say. So those are the ones which I definitely want to change. Then there is another registry setting. If you are using OLTP, a busy OLTP system really can benefit from the alternate page cleaning. So make sure that you, for OLTP purposes, turn on the DB2 use alternate page cleaning. It's by default, it's not there, not in the registry, so it's off, and therefore it can be very late before the page cleaners kick in. Told you already a lot about this Nmon tool. Nmon is a really nice tool. It's a free hardware monitor. It runs on AIX and Linux, and it can give you real-time figures. So you turn that on, you can say, I want to see the CPU, memory, disk I/O statistics, etc. But one of the nice things also is that you can capture that information and write it to a file. And again, on DeveloperWorks, you can find a spreadsheet with built-in macros, which absorb that file and turn all that information into the spreadsheet. And that is so good, is that if you're a consultant, definitely this can give you the wow with the customers, like, well, we've done some monitoring and here are some results. And so that is a very nice tool. It's, I think, the best hardware monitor available, and it's for free. Okay, we've seen the hardware, we've seen the config. There was one more component, which was the SQL, right? So when we are looking at SQL, actually, Steve Rees, who unfortunately no longer works with the Db2 Lab, but when he was working for the Db2 Lab, he wrote this piece of information to find out on what's going on within your server, is who's doing what, where's Db2 spending time. And so you could come to the conclusion that, for instance, it is your SQL, but maybe it's not. Maybe it's the log, maybe it's the who knows what. So the first question we have to ask ourselves, is it really SQL or is it something else within the server? And so with this flowchart, you could say, you can actually find out what's going on. But in order to use this flowchart, we need the figures, right? So where do we get the figures from? Well, Db2 has a very nice feature built in. There is a store procedure called db summary. And you just call that store procedure. You give as a parameter the number of seconds it should run. And it collects. It just does do a number of mon-gets. And it calculates the deltas. And it spits out a very nice report. The figures from this report can help you making the decisions in that flowchart. And then you might come to the conclusion, oops, it's the SQL. But tuning SQL, that's a totally different story. I want to come back next year and talk about tuning SQL. But this is now for the server, and we have to know that it's not the server, not the Db2. So is everything configured correctly? And are things performing like I think they are? And this report brings in, it breaks down into a number of sections. And so as you can see over here, this is the weighting section where that tells you in very high detail on where the time is spent if there's weights going on, for instance. And so we can say, for instance, well, the transactions aren't performing very well, but it's all in the weighting, and the weighting is because of you can see that the buffer pools are actually waiting on I/O, and therefore there must be a problem in the I/O area or something like that. So this is a tool which can help you to point you into the right direction in what's going on here. So it's built in within Db2, and also, like I said, for instance, with the package cache, there's figures in there which tells you how many compiles are going on, how many package cache inserts and how many package cache lookups are done. And if the package cache is too small, you will see that the compiles are done a lot, you can say. Whereas over here, in this example, you can see that there are actually over 8,000 SQLs passing through in this period I was measuring, and only 218 were compiled. Maybe that's still not enough, you could say. Maybe I want to increase the package cache. But definitely, analyzing this report, the DBA can look at all the figures and say, this is good or this is bad. Like this DBA in the picture, he looks at the bad and he says, that's not a good sign. So That is where you use this thing for. Okay, we've come to the conclusion it is SQL, right? So now what? Well, we have to do SQL tuning. So I can tell you a little bit about SQL tuning. First of all, keep calm and may the odds be in your favor. And let's do a bit of SQL tuning. But before we do SQL tuning, I have to tell you about two bad guys. And the bad guys are the mappers and the stringers. So who are the mappers? The mappers are the object relational mappers. And they come in different flavors. They call themselves abstraction layers. They call themselves active records. They call themselves ORMs. So the further you go on the list, the worse the performance gets. So the full-scale ORMs, like Hibernate, are typically a source of problems, you could say. They're a problem two ways. One is the SQL which it generates can be huge. And the second one is I have no clue on how to deal with that. Well, if you are using Hibernate and you have no clue on what Hibernate is, you are actually using a space rocket to go to the supermarket and you have no clue how to control this thing except turn it on and turn it off. That is not a good thing. So make sure that you are understanding Hibernate and that you can go behind the curtain and, for instance, turn off eager fetching. That makes the queries smaller and therefore much easier for DB2 to resolve. And also what you see is that if the eager fetching is off, you see that you don't spend a lot of time fetching stuff which you are actually never using. So if you are using a object relational mapper, I know it's not the call for the DBA to decide on that, but if you are using an ORM, make sure that you understand the ORM. The second bad guy is the stringer. The stringer is a piece of application which actually never ever uses a host variable. And that means that they go through a database and they repeat the same query again and again and again, but every time with a different literal in it. Although the SQL for the rest is the same, like over here in the example, employee number is 20, employee number is 70. And to DB2, those are two different queries, and the second one has to be optimized again. What you see typically if you have this string thing going on is that your package cache tends to explode. You make it bigger and it's not big enough, and you make it even bigger and it's not big enough. Then that is a clear sign that you want to look what's inside the package cache, and you very often spot it immediately. And what you do then is you go to the database configuration and you use the statement concentrator. You say to the statement concentrator that you want to use literals. That default is off. So statement concentrator is set to literals, and therefore the optimizer takes the time to look at, if I substitute the literals by parameter markers, can I find the same statement in the package cache? If not, I unfortunately have to compile it, but if I can find it, I already have it compiled. And I just have to plug in the literals over here. That can make a huge difference. That I've seen package caches coming down from several gigabytes to megabytes again. So this is a very important thing if you have the wrong software, you could say, because that's what it is. It's typically a bought package which does do that. Okay, those are the two bad guys. How do I find my bad SQL? Well, we consult with our friend Amber. Amber once wrote a blog which she gave you this SQL statement. And what this SQL statement does, as you can see, it goes through the monget package cache over here in the query. And she does do that with a with statement. She first goes to the package cache, sums up all of the rows read, the CPU time, the execution time, and so on. And then she goes in and she tries to find statements which are actually using a certain percentage of that. So 10% of the rows read are contributed to this SQL, or 10% of the CPU is contributed to this SQL, and so on and so on. So is this perfect? No, it's not, because you typically find the elephants with this. You don't find the mosquitoes with this. Although the mosquitoes might fall out with the execution time. You say, well, these statements are actually using more than 10% of these execution time, but it's not a guarantee. So you have to go dig deeper and do all kinds of other things. And the mongets are perfect to do that, but be careful if you are doing that. And we're coming more or less to the end, is a little bit of a warning. There are rafts and there are yachts, and that's the same kind of difference of you monitoring yourself with mongets and a vendor having a perfect tool which you just do click, 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 and you're done. You find very rapidly what it is. And I can tell you these tools are perfected over years because there is a development team behind it. So, and our good friend Scott here, who runs the magnificent Db2Night show, has one of those tools. So make sure that you don't try to build a raft where you actually need a yacht. If you have any questions, make sure that you send them to me via the email. And that's more or less a wrap-up. Last kind of shameless plug, the Db2 Symposium is coming up again, and it will be in May 2019 in the Netherlands. It's probably going to be in the week of the 19th of May. And that's it, Scott. That's all I have to say.
That was a fantastic presentation. You had so many SQL examples, command examples, coaching guidelines. What an awesome presentation. And you know, if that's the caliber of the quality of education that you offer at your symposiums, people just got to be excited. I'm very impressed. Thank you so much for your presentation today. Really, really nice job. So let's see what we need to do here to wrap up. And slides. So that was Klaas. No commercials. Oh, here we go. We got to ask one last polling question. Ask people if they learned anything today. Here we are. Did you learn anything today? Let's get that out to the people that have stayed for the entire duration of today's information-packed show. Awesome. Going once, going twice. Nearly everybody has voted within 15 seconds. Closing the poll, sharing the results. Boom, 100%.
Okay, so, thank you, folks. Thank you.
Clearly, you delivered a lot of great information today. So thank you very much, attendees, for joining us. Thank you, Klaas and Kelly, for your presentations. There was a lot of good material there. Appreciate you.
You're welcome. Thank you.
And today's show is sponsored by DBI Software. DBI is your trusted partner for breakthrough Db2 performance solutions to deliver invaluable results for organizations having the most demanding requirements and discriminating preferences. As Klaas noted, DBI has built the yacht. That was great. And join us in about an hour and a half at 1 p.m. Central. We've got a webinar this afternoon. Find that on our events page. So there we go. Okay, now everybody can see the final slide. That's it. Klaas, have a great weekend. Kelly, you the same. Sounds like we're going to have Kelly back in the spring when that V-Next comes around. And I heard Klaas volunteer to come back and give us another session on SQL tuning. Is that right, Klaas?
Yeah, that's fine. I can do that.
I'll be in touch with you on some dates that we have available in the spring.
Perfect.
Thanks, guys.
Oh, thank you, everybody.
Thank you. Bye.
Bye-bye.